Hello and welcome to the Sleepy Astronomer. I'm so glad you've joined me tonight for this gentle journey into the science of blood moons. Tonight, we're exploring one of the most captivating sights the night sky has to offer, the blood moon. That moment when our familiar silver companion transforms into something ancient and otherworldly, glowing with the deep russet hues of autumn leaves or the warm copper of an old penny. It's a sight that has stopped humans in their tracks for thousands of years, inspiring everything from terror to wonder, from prayers to poetry. But what exactly is happening up there when the moon turns red? Why does our celestial neighbour, usually so cool and silver in its reflected sunlight, suddenly glow like an ember in the darkness? The answer involves a beautiful dance of shadows and light, a cosmic alignment that turns our entire planet into a giant lens, focusing and filtering the sun's rays in ways that paint the moon in colours that seem borrowed from sunset. In the chapters ahead, we'll wander through the gentle science behind this phenomenon. We'll discover why the moon doesn't simply disappear when Earth's shadow falls across it, but instead lights up in shades of red and orange and deep amber. We'll explore how our atmosphere becomes an artist's brush, painting the lunar surface with light that has travelled around the edges of our world. We'll also step back in time to see how different cultures have interpreted this celestial event, from ancient civilizations who saw omens in the blood-red moon to medieval astronomers who began to understand the mechanics behind the mystery. We'll visit the myths and legends that grew around these moments when the moon seemed to bleed in the sky. And because a blood moon may be gracing our skies soon, we'll talk about what to expect when you look up, how the transformation unfolds slowly, almost imperceptibly at first, then with growing drama as Earth's shadow creeps across the lunar surface, what it feels like to stand beneath a moon that glows like a coal in the hearth of the sky. This is more than just an astronomical event. It's a reminder of our place in the cosmic dance, a moment when we can actually see the mechanics of the solar system playing out above our heads. It's proof that we live on a spinning ball of rock and water, casting shadows into space, with a moon that faithfully follows us around the sun. So, settle in, breathe deeply, and let's drift together into the warm red light of the blood moon. Let's discover why this ancient sight continues to move us, how science explains its beauty, and what it means to be human beings looking up at a universe that never stops surprising us with its quiet wonders. The night is calling, the moon is waiting, and the story of the blood moon is about to unfold in all its gentle cosmic glory. Imagine stepping outside on an ordinary evening and glancing up at the moon, expecting to see that familiar silver disk hanging peacefully in the darkness. But instead, you find something that stops you in your tracks. The moon glows a deep, dusky red, like an ember cooling in a fireplace, or the last light of sunset trapped in the sky. It's still unmistakably the moon. You can see its craters and maria, those dark patches we sometimes call seas, but it looks as though it's been dipped in warm copper or brushed with the colours of autumn. The sight is both familiar and utterly alien. Your eyes tell you it's the moon, that same celestial companion you've looked up at countless times before. But your mind struggles to reconcile what you're seeing. There's an almost otherworldly quality to the light, softer than the moon's usual brilliance, warmer than its typical cool glow. The red light seems to pulse gently, like the rhythmic breathing of some vast, sleeping creature in the sky. If you've never seen a blood moon before, the experience can be genuinely startling. There's something primal about seeing the moon transformed this way, something that reaches back to the deepest parts of our evolutionary memory, when changes in the sky might have meant danger or significance beyond our understanding. This is a blood moon, and it's one of those rare astronomical events that manages to be both scientifically fascinating and mysteriously beautiful at the same time. Unlike a new moon, which disappears entirely from view, or a normal full moon, which shines bright silver white, a blood moon glows with an otherworldly light that seems borrowed from dreams. The name itself carries weight. Blood moon sounds dramatic, almost ominous, and throughout history it has indeed stirred deep emotions in those who witnessed it. But the blood moon is not a separate celestial body or a sign of cosmic upheaval. It's simply our familiar lunar companion caught in a very special kind of shadow, Earth's shadow, and lit by a very particular kind of light. To understand what creates this stunning transformation, we need to think about shadows for a moment. Not the simple, sharp-edged shadows cast by a lamp or a tree, but the complex layered shadows that a sphere creates in space. When Earth sits between the sun and the moon, it casts a shadow into space behind it, just as you cast a shadow when you stand in front of a bright light. But Earth's shadow is not a simple black void. It has structure, depth, and different regions with their own characteristics. Picture Earth's shadow stretching out into space like a long, dark cone. The very darkest part, where no direct sunlight can reach, is called the umbra. It's the shadow's heart, the place where Earth completely blocks the sun's light. Surrounding this dark core is a lighter region called the penumbra, where Earth blocks only some of the sun's light, creating a gentler, more gradual shadow. But Earth's shadow is not like the simple shadow you cast when you stand in front of a lamp, because Earth is roughly 12,800 kilometers across, and the Sun is about 1.4 million kilometers in diameter. The geometry creates something more complex. The shadow cone narrows as it extends into space, growing smaller and smaller until it eventually fades into the cosmic background. At the Moon's distance, about 384,000 kilometers away, Earth's umbra is still about 9,200 kilometers across, easily large enough to swallow our Moon, which is only 3,474 kilometers in diameter. The penumbra extends even farther, creating a region of partial shadow that can stretch for hundreds of thousands of kilometers beyond the umbra's edge. This means that as the Moon approaches Earth's shadow, it doesn't suddenly plunge from bright sunlight into complete darkness. Instead, it gradually enters a zone where Earth blocks increasing amounts of sunlight, creating a slow, subtle dimming that can last for hours. When the Moon drifts into Earth's penumbra, it dims slightly, but the change is so subtle that most people don't even notice. It's like walking into a room where someone has dimmed the lights just a little. You sense something has changed, but you might not be able to put your finger on exactly what. But when the Moon moves deeper, sliding into the umbra, that's when the real magic begins. You might expect that when the Moon enters the umbra, it would simply vanish, snuffed out like a candle in the wind. After all, if Earth is completely blocking the sun's light, how can the Moon continue to glow? The answer lies in our atmosphere, that thin envelope of air that surrounds our planet and makes life possible. Our atmosphere is more than just the air we breathe. It's a complex, layered blanket of gases that extends hundreds of kilometers into space, growing thinner and thinner until it gradually merges with the vacuum beyond. And this atmospheric blanket has a remarkable property. It bends light. Think of our atmosphere as a giant magnifying glass wrapped around the entire planet. Just as a lens can focus light or bend it in different directions, our atmosphere refracts sunlight as it passes through. This happens because light travels at different speeds through different materials. It moves faster through the vacuum of space, than it does through air, and this change in speed causes the light rays to bend. The effect is strongest at the edges of our planet, where sunlight has to travel through the greatest thickness of atmosphere before continuing into space. Here, along Earth's limb, the atmosphere acts like a lens hundreds of kilometers thick, bending the sun's rays around the curve of our world and redirecting them into the shadow zone beyond. When sunlight hits Earth's atmosphere, something beautiful happens. The atmosphere acts like a lens, refracting or bending the sun's rays around the edges of our planet. Some of this bent light curves around Earth's limb and continues on toward the moon, carrying with it the colours of every sunrise and sunset happening on Earth at that moment. But here's where it gets really interesting. Not all colours of sunlight bend equally as they pass through our atmosphere. The shorter wavelengths, the blues and violets, scatter away more easily, bouncing off molecules in the air and spreading in all directions. This is the same process that makes our sky blue during the day and our sunsets red and orange in the evening. The longer wavelengths, the reds, oranges and deep yellows, are more stubborn. They push through the atmosphere more easily, bending around Earth's edge and continuing their journey through space. By the time this filtered sunlight reaches the moon during an eclipse, it has been stripped of its blues and violets, leaving behind the warm, rich colours of the red end of the spectrum. So when you look up at a blood moon, you're seeing something remarkable. The moon illuminated by the combined light of every sunrise and sunset on Earth, filtered through hundreds of miles of atmosphere, and focused by our planet's gravity into a gentle reddish glow. The colour of a blood moon isn't always the same. Sometimes it appears a deep, dark red, like dried blood or burgundy wine. Other times it glows a bright copper orange or even a pale peachy hue. These variations depend on what's happening in Earth's atmosphere at the time of the eclipse. If there are volcanic eruptions sending ash and particles high into the atmosphere, or if there are dust storms or forest fires, these can affect how light filters through the air, making the moon appear darker and more deeply red. On the other hand, if the atmosphere is particularly clear and clean, more light gets through and the moon might appear brighter and more orange. In very rare cases, when conditions are just right, the moon can even appear yellow or pale gold during an eclipse. The transformation doesn't happen all at once. A lunar eclipse unfolds slowly, like a cosmic ballet performed in slow motion. First, the moon slides into the penumbra, dimming almost imperceptibly. If you weren't specifically watching for it, you might not even notice this initial change. The moon's glow simply seems a little less bright, a little less crisp around the edges. Then gradually Earth's shadow begins to creep across the lunar surface, moving from one edge toward the other like a curved darkness eating away at the bright disk. The shadow has a distinct shape. It's curved, following the outline of Earth's spherical form. Ancient Greek philosophers actually used this curved shadow as evidence that Earth was round, not flat, reasoning that only a sphere could cast such a consistently curved shadow. The shadow moves slowly but relentlessly across the moon's face. If you watch carefully, you can actually see it progress in real time, though it's subtle, more like watching the hour hand of a clock than the second hand. As the shadow advances, it reveals the moon's topography in new ways. The mountains along the shadow's edge create tiny irregularities in the darkness, small scallops and bumps that show the rugged nature of the lunar landscape. As more and more of the moon disappears into the umbra, the remaining crescent grows thinner and thinner. The bright silver crescent contrasts dramatically with the deepening red of the shadowed portion, creating a striking visual that photographers often try to capture. This is the phase that builds the most anticipation. You can sense that complete totality is approaching. Finally, the last silver edge vanishes, and the entire moon is swathed in Earth's shadow. But instead of disappearing completely, it emerges from the darkness transformed, glowing with that warm red light that gives the blood moon its name. The moment of first totality is often breathtaking. After watching the moon slowly disappear piece by piece, seeing it suddenly reappear as a glowing red orb can feel almost magical. During totality, the moon often seems smaller and dimmer than usual, hanging like a distant lantern in the sky. The red light is much fainter than the moon's normal reflected sunlight, so faint stars that are usually washed out by moonlight become visible around it. The whole nighttime landscape takes on a different quality, darker than a normal full moon night, but with an eerie, warm glow that's unlike anything else in nature. The entire process can take several hours from start to finish, with the period of totality when the moon is completely within Earth's shadow, lasting anywhere from a few minutes to over an hour, depending on how the moon's orbit carries it through the shadow. The longest possible totality lasts about 107 minutes, though most are considerably shorter. Standing beneath a blood moon is an experience that connects you directly to the mechanics of the solar system. You're seeing in real time the proof that we live on a sphere floating in space. Earth's round shadow tells the story of our planet's shape, while the reddish light painting the moon reveals the nature of our atmosphere and the journey of sunlight across vast distances. It's also a reminder of how interconnected everything is in our cosmic neighborhood. The same atmosphere that gives us blue skies and orange sunsets also creates the blood moon's glow. The same gravity that keeps us planted on Earth's surface also shapes the shadow that transforms our view of the moon. In many ways, a blood moon is astronomy made visible, a moment when the usually invisible workings of the solar system reveal themselves to anyone who takes the time to look up. It's science you can see with your naked eye, a natural phenomenon that requires no telescope or special equipment to appreciate, just patience and wonder. And perhaps that's part of what makes blood moons so compelling. In our age of complex instruments and abstract theories, here's a cosmic event that connects us directly to the same sense of awe and curiosity that has driven human beings to study the sky for thousands of years. When you see a blood moon, you're sharing an experience with every human who has ever looked up in wonder at the night sky, seeing the same transformation that has puzzled and inspired our species since we first began to pay attention to the dance of celestial bodies above our heads. As we prepare to explore more about why the moon turns red, how different cultures have interpreted this phenomenon, and what to expect when you witness one yourself, remember that you're about to become part of a story that stretches back to the very beginning of human civilization, a story written in light and shadow across the vast canvas of space. To understand why a blood moon glows red, we need to take a journey through light itself. Not the simple, everyday light that illuminates your morning coffee or streams through your window, but light as a wave, as energy, as a traveller that has crossed 150 million kilometres from the sun, only to be transformed by our atmosphere into something altogether different. Light, you see, is not the uniform white glow it appears to be. Hidden within that seemingly simple beam from the sun is an entire rainbow of colours, each with its own character, its own wavelength and its own way of behaving, when it encounters the molecules and particles that make up Earth's atmosphere. When sunlight hits a prism, we see this hidden complexity revealed. The white light separates into red, orange, yellow, green, blue, indigo, and violet, each colour distinct and pure. The same thing happens in our atmosphere, though it's far more subtle than the dramatic splitting you see with a glass prism. Every time sunlight enters Earth's atmosphere, it begins to interact with the countless molecules of nitrogen, oxygen, water vapour, and dust that float suspended in the air. These interactions determine which colours of light reach our eyes and which ones are scattered away into other directions. The key to understanding the blood moon lies in a phenomenon called Rayleigh scattering, named after Lord Rayleigh, a British physicist who first described it mathematically in the late 19th century. It's the same process that paints our daytime sky blue and our sunsets red, and it works because of a simple but profound principle. Shorter wavelengths of light scatter more than longer wavelengths. Think of it this way. Blue light has a shorter wavelength, about 450 nanometers, while red light has a longer wavelength of about 650 nanometers. When these different wavelengths encounter tiny particles in the atmosphere, the blue light bounces around like a pinball, scattering in all directions. The red light, meanwhile, tends to push through more directly, less affected by the molecular obstacles in its path. During the day, this scattering creates the blue sky we're familiar with. The sun's white light enters our atmosphere from above, and the blue wavelengths get scattered in every direction by the molecules in the air. No matter where you look in the sky, some of that scattered blue light is reaching your eyes, creating the soft blue dome overhead. Meanwhile, the red light passes through more directly, which is why the sun itself appears white or yellow when it's high in the sky. You're seeing the light that hasn't been scattered away. But as the sun gets lower on the horizon, something interesting happens. The sunlight has to travel through much more atmosphere to reach your eyes. Instead of passing through perhaps 100 kilometers of air when the sun is overhead, the light now has to traverse hundreds or even thousands of kilometers of atmosphere, passing through layers of varying density, humidity, and particle content. The longer this journey through the atmosphere, the more opportunities there are for scattering. By the time the sun is setting, almost all of the blue light has been scattered away, bouncing off molecules and particles and spreading across the sky in directions that don't reach your eyes directly. What's left is the light that's most stubborn about travelling in straight lines, the reds, oranges, and yellows. This is why sunsets are red. You're seeing the light that has survived the long journey through the atmosphere, the wavelengths that are best at pushing through the molecular maze of our air without being diverted from their path. Now, during a lunar eclipse, something similar but even more extreme happens. The sunlight that reaches the moon during totality has travelled not just through a thick layer of atmosphere, but around the entire edge of our planet. Imagine every sunrise and sunset happening on Earth at that moment. The light from all of them is being bent and filtered by our atmosphere, and some of it is being redirected toward the moon. This light has been through an extraordinary journey. It started at the sun, travelled 150 million kilometres to Earth, then grazed the edge of our planet, bending through hundreds of kilometres of atmosphere, before continuing another 384,000 kilometres to the moon. By the time it arrives, it has been filtered and refined, stripped of its blues and violets, leaving behind only the warm, long wavelengths that can survive such an epic voyage. The atmosphere acts as a filter, but it's more sophisticated than any filter you might put on a camera. It's a selective filter that operates based on the fundamental physics of light and matter. The molecules in our air, mostly nitrogen and oxygen, are much smaller than the wavelengths of visible light, which is exactly the condition needed for Rayleigh scattering to occur. If our atmosphere contained larger particles, say if Earth were perpetually shrouded in dust storms like Mars sometimes is, the scattering would work differently. Large particles scatter all wavelengths more equally, which is why light through heavy dust or smoke appears white or grey rather than blue or red. But our relatively clean atmosphere, with its molecular-sized particles, creates the perfect conditions for wavelength-dependent scattering. The amount of scattering follows a precise mathematical relationship. The intensity of scattered light is inversely proportional to the fourth power of the wavelength. This means that blue light, with its shorter wavelength, is scattered about 5 times more strongly than red light. It's not a subtle difference. It's dramatic enough to completely transform the colour of light that travels long distances through the atmosphere. To put this in perspective, imagine 2 runners in a marathon. The blue light is like a runner who gets distracted by every interesting sight along the route, constantly veering off the path to explore side streets and chat with spectators. Meanwhile, the red light is the focused marathoner who keeps their eyes on the finish line, pushing steadily forward despite the obstacles. By the time both reach the end of the race, the focused runner arrives strong and direct, while the easily distracted runner has expended energy in all directions and may not even finish at the intended destination. This is why the most spectacular sunsets often happen when there's dust or moisture in the air. The additional particles provide even more opportunities for blue light to scatter, leaving behind an even purer concentration of reds and oranges. Desert sunsets can be particularly stunning because the fine dust particles suspended in the dry air are perfect for this selective scattering. During a lunar eclipse, the light that illuminates the moon has essentially travelled through the equivalent of every sunset and sunrise on Earth simultaneously. Think about that for a moment. All around our planet's edge, sunlight is grazing the atmosphere, being filtered and bent. The Arctic sunset, the tropical dawn, the temperate twilight, light from all of these regions is being focused toward the moon by our atmosphere's refractive properties. But the journey doesn't end with simple filtering. Our atmosphere also acts as a lens, bending the light through refraction. Just as a glass lens can focus light by changing its direction, our atmosphere bends sunlight around Earth's curvature. This happens because light travels at different speeds through different materials. In the vacuum of space, light travels at its maximum speed, but when it enters our atmosphere, it slows down slightly, and this change in speed causes the light rays to bend. The bending is strongest where the atmosphere is thickest and becomes gentler as the air thins out at higher altitudes. This creates a gradient that acts like a lens, focusing some of the sun's light that would otherwise miss the moon entirely. Without this atmospheric refraction, lunar eclipses would be darker, perhaps dark enough that the moon would disappear completely during totality. The colour of the blood moon also depends on the current state of Earth's atmosphere. If there are volcanic eruptions pumping ash and sulfur compounds into the stratosphere, these particles can absorb and scatter light differently, making the moon appear darker and redder. Major volcanic eruptions can affect the colour of lunar eclipses for months or even years afterward. The 1991 eruption of Mount Pinatubo in the Philippines, for example, injected so much ash and sulfur dioxide into the stratosphere that lunar eclipses for the next several years appeared much darker and redder than usual. The particles didn't just scatter light, they also absorbed it, reducing the overall amount of illumination reaching the moon and intensifying the red coloration of what remained. Similarly, dust storms, forest fires, and even pollution can influence the blood moon's appearance. A particularly clean atmosphere might allow more yellow and orange wavelength through, making the moon appear brighter and more copper-coloured. A dusty or smoky atmosphere tends to absorb more light overall, creating a darker, more deeply red eclipse. The seasonal timing of an eclipse also matters. Winter air tends to be cleaner and drier, often producing brighter, more orange blood moons. Summer air, especially in regions affected by wildfires or dust storms, can create the deep, dark red eclipses that most closely match the blood moon description. Even the time of day affects the appearance. An eclipse that occurs when it's sunset on one side of Earth and sunrise on the other will be illuminated by light that's travelling through different atmospheric conditions. The sunset side might contribute warmer, redder light if there's dust or moisture in the air, while the sunrise side might add cooler, more orange tones if the air is cleaner. Weather patterns also play a role. The temperature, humidity, and pressure variations in different parts of Earth's atmosphere can affect how light bends and scatters. A high-pressure system with clear, stable air allows light to pass through more efficiently than a region with turbulent, moisture-laden air. This is why no two blood moons look exactly alike. Each one is lit by a unique combination of atmospheric conditions around our planet's edge. The volcanic activity, the weather patterns, the seasonal variations in atmospheric density. All of these factors combine to create a fingerprint of light that's specific to that moment in time. There's something almost poetic about the physics involved. The same molecular interactions that create the blue sky you see on a clear day and the red sunset that takes your breath away are also responsible for the ethereal glow of a blood moon. It's all connected. The same atmosphere that sustains life on our planet also creates the optical effects that paint our moon in shades of copper and crimson. The light that colours the blood moon has been on an incredible journey. It began in the nuclear furnace of the sun, where hydrogen atoms fuse into helium, releasing energy that eventually becomes the photons we see as sunlight. These photons travel across the vacuum of space at 300,000 kilometers per second, carrying with them the energy that drives weather, photosynthesis, and countless other processes on Earth. When this light encounters our atmosphere during a lunar eclipse, it becomes part of a grand optical experiment. Our entire planet becomes a filter and a lens, selecting certain wavelengths and focusing them toward the moon. The blue light that might have illuminated a daytime sky is scattered away. The green light that plants use for photosynthesis is absorbed or redirected. What remains is the warm, red light that can complete the journey, light that carries within it the signature of every part of Earth's atmosphere it has passed through. Standing beneath a blood moon, you're seeing the combined optical effects of our entire planet's atmosphere. Every molecule of air, every particle of dust, every droplet of water vapor contributes to the light that colors the moon. In a very real sense, the blood moon is illuminated by the breath of our living planet, filtered through the same air that fills your lungs and processed by the same physical laws that govern the behavior of light throughout the universe. As we continue our exploration of blood moons from their historical significance to what it's like to witness one unfold in real time, remember that behind the mystery and the mythology lies this elegant dance of light and matter. The next time you see a blue sky or a red sunset, you'll know you're witnessing the same fundamental processes that transform our familiar silver moon into a glowing ember in the night sky, connecting the everyday beauty of our atmosphere to the rare magic of a blood moon. Long before telescopes revealed the mechanics of celestial motion, long before we understood the dance of shadows and light that creates a blood moon, human beings looked up at the night sky and witnessed something that stopped them in their tracks. There, hanging in the darkness where the familiar silver moon should be, glowed an ember the colour of dried blood or burnished copper. Without the comfort of scientific explanation, our ancestors had to make sense of this transformation using the tools they had: observation, pattern recognition, and the stories that help humans navigate mystery. The earliest recorded observations of lunar eclipses stretch back over 4,000 years. In ancient Babylon, astronomers kept meticulous records of celestial events, including what they called the moon becoming dark. These weren't casual observations. They were part of a sophisticated system for tracking time and predicting future eclipses. Babylonian astronomers discovered that lunar eclipses follow a pattern, repeating in cycles that last about 18 years and 11 days, a period they called the Saros cycle. But for them, accurate prediction didn't diminish the drama of witnessing the event itself. Clay tablets from around 2000 BCE describe the moon being devoured and turning the color of blood. Even with their mathematical precision, the Babylonians understood that this was no ordinary celestial event. The transformation of the moon touched something deeper than mere calculation. It spoke to the fundamental mystery of existence itself. In ancient China, astronomers and court officials maintained equally careful records, though they interpreted the events differently. Chinese texts from the Han Dynasty describe lunar eclipses as times when the celestial dog devours the moon, or when the moon becomes like blood. The Chinese developed their own predictive methods, and by the time of the Tang dynasty, they could forecast eclipses with remarkable accuracy. What's striking about these early records is not just their precision, but their consistency in describing the moon's colour during totality. Across cultures separated by thousands of miles and hundreds of years, observers used remarkably similar language: blood red, copper-coloured, the hue of rust or dying embers. This wasn't poetic license. They were recording what they actually saw, the result of Earth's atmosphere filtering sunlight in ways they couldn't yet understand. The ancient Greeks brought a different perspective to lunar eclipses. Rather than seeing them primarily as omens or supernatural events, Greek philosophers began to treat them as natural phenomena that could be explained through observation and reasoning. Aristotle, writing in the 4th century BCE, correctly identified lunar eclipses as Earth casting a shadow on the moon. He even used the consistently round shape of this shadow as evidence that Earth itself must be spherical, one of the earliest logical proofs of our planet's shape. Greek astronomers like Hipparchus used lunar eclipses as scientific tools, timing them precisely to calculate the relative sizes and distances of Earth, Moon, and Sun. But even as they developed these mathematical approaches, Greek observers continued to be moved by the visual drama of the event. The historian Thucydides described a lunar eclipse during the Peloponnesian War, noting how the blood-red moon affected the morale of soldiers and sailors who interpreted it as an omen of doom. The Romans inherited much of Greek astronomical knowledge, but they added their own cultural interpretations. Roman historians recorded numerous lunar eclipses, often in connection with significant political or military events. Pliny the Elder wrote about eclipses with the systematic curiosity of a natural historian, describing not just the timing and appearance, but also the public reaction to these events. He noted that even educated Romans, who understood the astronomical causes, still felt a visceral unease when witnessing the moon transform from silver to red. Medieval Islamic astronomers made extraordinary advances in eclipse prediction and observation. Working from observatories in Baghdad, Damascus, and Cordoba, scholars like al-Battani refined the mathematical models for predicting eclipses with greater precision than had ever been achieved. They developed sophisticated instruments for timing eclipses and measuring the exact colors and brightness of the eclipsed moon. The House of Wisdom in Baghdad became a center for eclipse studies, where scholars from different cultures shared their observations and techniques. These astronomers weren't content to simply predict when eclipses would occur. They wanted to understand the subtle variations in how they appeared. They noted that some eclipses produced moons the colour of burnished bronze, while others created deep crimson orbs that seemed to pulse with their own inner light. One particularly detailed account comes from the 11th century Persian astronomer Ibn al-Haytham, who described a lunar eclipse visible from Cairo with almost poetic precision. He wrote of the moon's transformation from the pure light of silver to the warm glow of heated copper, noting how the colour seemed to pulse and shift throughout totality. His observations included details about how the eclipse affected the surrounding landscape, how shadows became softer, how the night sound seemed muted, how even animals appeared to sense that something unusual was happening in the sky. Ibn al-Haytham also noted something that modern observers continue to experience, the way time seems to slow during a blood moon. The moments of totality stretch like honey poured from a jar, he wrote, each second weighted with wonder. His descriptions capture not just the scientific aspects of the eclipse, but the profound psychological impact of witnessing such a transformation. During the European Renaissance, as printing presses spread knowledge more widely, accounts of blood moons began reaching broader audiences. The German astronomer Johannes Kepler wrote extensively about a lunar eclipse he observed in 1620, describing not just the scientific aspects but also the emotional impact of watching the familiar moon transform. He noted that even knowing the cause didn't diminish the wonder of witnessing the event. "The moon hangs like a coal in the furnace of night," Kepler wrote, "and though reason tells us why, the heart still quickens at the sight." Galileo Galilei observed several lunar eclipses through his telescope, making detailed drawings of the lunar surface during different phases of eclipses. His sketches show not just the progression of Earth's shadow, but also how the red light during totality revealed lunar features in ways that normal moonlight never did. Mountains cast different shadows, the Maria appeared with altered contrast, and the overall three-dimensional quality of the lunar surface became more apparent. The colonization of the Americas brought new opportunities for eclipse observation across different longitudes. European settlers and Native American cultures shared eclipse experiences, though with vastly different interpretive frameworks. Native American traditions had their own rich heritage of lunar eclipse observations, often incorporating them into seasonal calendars and ceremonial cycles. One of the most famous historical lunar eclipses occurred in 1504 during Christopher Columbus's fourth voyage to the Americas. Stranded in Jamaica and facing increasingly hostile relations with the local Taíno people, Columbus used his knowledge of an upcoming lunar eclipse to his advantage. He told the Taíno leaders that his god would make the moon inflamed with wrath if they didn't provide supplies to his crew. When the blood moon appeared as Columbus had predicted, the Taíno interpreted this as evidence of his supernatural power and agreed to help his expedition. While this episode reflects the colonial manipulation of indigenous peoples, it also demonstrates how lunar eclipses served as reliable chronological markers that could be predicted and used for practical purposes. The 18th and 19th centuries brought increasingly sophisticated instruments for observing lunar eclipses. Astronomers began using telescopes not just to watch the progression of Earth's shadow, but to study the colours and brightness variations during totality. They developed photometers to measure the exact amount of light reaching Earth from the eclipsed moon, and early spectroscopes to analyse the composition of the filtered sunlight. During this period, eclipse observation became more systematic and collaborative. The Royal Society in London began coordinating observations across the British Empire, while French astronomers worked with colleagues across continental Europe to gather data from multiple locations simultaneously. This collaborative approach revealed that the same eclipse could appear quite different when viewed from different parts of Earth, depending on local atmospheric conditions and the angle of observation. British astronomer Francis Baily made particularly detailed observations of the eclipse of 1833, noting that the moon's colour varied from deep copper near the centre of Earth's shadow to bright orange near the edges. His careful timing of the eclipse phases allowed him to refine calculations of Earth's atmospheric height, as the refraction of sunlight around our planet's edge provided clues about the density and extent of our atmosphere. Baily also made another important observation that continues to fascinate eclipse watchers today: the way the eclipsed moon seems to reveal stars that are normally invisible near the full moon. During totality, with the moon's brightness dramatically reduced, faint stars that would usually be washed out by moonlight became clearly visible in the same field of view. This created an almost magical effect, as though the blood moon was suspended among a field of diamonds. The advent of photography in the mid-19th century revolutionized eclipse observation. The first successful photographs of a lunar eclipse were made in 1863, capturing not just the event, but preserving the subtle gradations of colour that had previously existed only in written descriptions or artistic renderings. These early photographs confirmed what observers had been reporting for millennia, that the eclipsed moon truly did glow with shades of red, orange and copper. By the late 19th century, networks of observers around the world were coordinating their eclipse observations, comparing notes on timing, colour and brightness. The global nature of these observations helped scientists understand that atmospheric conditions, volcanic eruptions, dust storms, seasonal weather patterns, affected the appearance of blood moons in predictable ways. The 1883 eruption of Krakatoa, for instance, injected so much ash and sulfur compounds into the atmosphere that lunar eclipses for the next 2 years appeared unusually dark and deeply red. Observers from London to Sydney reported that the moon seemed to nearly disappear during totality, glowing with just the faintest crimson light. As we moved into the 20th century, lunar eclipse observations became part of larger scientific programs studying Earth's atmosphere, climate patterns, and even the effects of human industrial activity on air quality. The 1963 eclipse, occurring shortly after several major volcanic eruptions, appeared so dark that some observers initially thought they were witnessing a partial rather than total eclipse. Throughout this long history of observation and interpretation, one element remained constant: the profound human response to witnessing a blood moon. Whether recorded by Babylonian astronomers, Islamic scholars, Renaissance scientists, or modern astrophotographers, the accounts consistently describe not just the mechanics of the event, but its emotional impact. There's something about seeing the moon transformed that reaches deeper than scientific understanding. Even today, with our complete knowledge of the physics involved, people who witness their first blood moon often describe feeling a sense of awe that's difficult to put into words. It connects us to every generation of human beings who have looked up in wonder at this cosmic spectacle. The historical record of blood moon observations also reveals how this celestial event has served as a bridge between cultures and centuries. The same moon that glowed red over ancient Babylon also appeared to Galileo's telescope, to Columbus's stranded expedition, to photographers in the 19th century, and to anyone who looks up during a lunar eclipse today. Across all the changes in human civilization, the blood moon remains a constant, a shared experience that connects us to our past and to each other. As we prepare to explore the myths and legends that cultures around the world have woven around this phenomenon, remember that we're part of this unbroken chain of observers. The next time you witness a blood moon, you'll be continuing a tradition of wonder and curiosity that stretches back to the very beginning of human civilization, adding your own moment of awe to a story that began when our species first looked up and tried to make sense of the dancing lights in the night sky. When the moon turned red in the night sky, our ancestors didn't just observe, they wove stories. Without the framework of modern astronomy to explain why their familiar silver companion had transformed into something the colour of blood or burnished copper, they reached for the tools humans have always used to make sense of mystery, narrative, symbolism, and the deep patterns that connect earthly experience to celestial events. These stories weren't mere superstition or primitive attempts at explanation. They were sophisticated ways of processing profound experiences, of capturing the emotional and spiritual impact of witnessing something that challenged the normal order of things. The blood moon became a character in humanity's oldest stories, a bridge between the known and unknown, the earthly and the divine. In Norse mythology, the blood moon was a sign of Ragnarök, the twilight of the gods. According to the ancient texts, when the moon appeared red and diminished, it meant that the great wolf Fenrir was finally succeeding in his eternal hunt to devour it. The red colour was seen as the moon's lifeblood seeping away as the cosmic predator's jaws closed around it. During these times, Viking communities would gather in their longhouses, beating drums and shouting to frighten away the wolf and save their lunar guardian. The imagery is visceral and immediate, a moon being consumed, its silver light replaced by the warm red of blood. You can almost hear the rhythmic pounding of drums echoing across the fjords, voices raised in defiant song under a sky where the familiar order had been disrupted. For the Norse, the blood moon wasn't just an astronomical event, it was a battle between order and chaos, light and darkness, played out on the canvas of the night sky. Similar themes of celestial predation appear in cultures around the world. In ancient China, the lunar eclipse was attributed to a celestial dragon attempting to swallow the moon. The Chinese word for eclipse, shi, literally means to eat. And during blood moons, communities would emerge from their homes with pots, pans, gongs, and drums, creating a cacophony designed to scare the dragon away from its lunar feast. The imagery these myths evoke is remarkably consistent across cultures that had no contact with each other. The idea of something powerful and hungry in the sky, something that could devour light itself, appears in the mythologies of peoples separated by oceans and centuries. This suggests something deeper than mere coincidence, perhaps a fundamental human response to witnessing the familiar becoming strange, the reliable becoming unpredictable. In Hindu tradition, the blood moon is connected to the demon Rahu, a serpentine figure who periodically swallows the moon in revenge for a perceived slight. According to legend, Rahu was once mortal but achieved immortality by drinking Amrita, the nectar of the gods. However, the sun and moon discovered his deception and reported it to the gods. As punishment, Rahu's head was severed from his body, but because he had already consumed the divine nectar, both parts remained alive. The head became Rahu, forever pursuing the sun and moon across the sky, occasionally catching and devouring them. The Hindu myth explains not just the eclipse itself, but also why the moon eventually returns to normal. Because Rahu has no body, the moon simply passes through him and emerges unharmed. It's an elegant narrative solution to the puzzle of why eclipses are temporary, and it transforms the blood moon from a moment of terror into part of an eternal cosmic dance. Many Native American cultures developed their own rich mythologies around lunar eclipses. The Lakota tell of a giant bear that climbs into the sky to claw at the moon, leaving it wounded and bleeding its red light across the night. The Hoopa people of Northern California believed that the moon had many pets, including mountain lions and snakes, and that when these creatures became ill, the moon's worry would cause it to blush with concern, turning red with emotional distress. These stories reveal something beautiful about how different cultures understood the relationship between earthly and celestial events. The moon wasn't just a distant object in the sky, it was a participant in the dramas of life, capable of emotion, vulnerable to attack, connected to the fate of creatures below. In some Pacific Northwest traditions, the blood moon was seen as a time when the moon was menstruating, a natural part of its feminine cycle that connected it to the rhythms of earthly fertility. During these times, certain ceremonies were performed to honor the moon's reproductive power, and it was considered a particularly auspicious time for rituals related to childbirth and harvest. This interpretation transforms the blood moon from an ominous event into a celebration of natural cycles, connecting the cosmic to the intimate, the celestial to the deeply personal rhythms of human life. The red color, rather than signaling danger or consumption, becomes a sign of the moon's participation in the fundamental creative forces of existence. Ancient Mesopotamian cultures saw blood moons as omens related to the health and fate of their rulers. The red moon was often interpreted as a warning to the king, perhaps of illness, military defeat, or political upheaval. Royal astronomers kept careful records not just of when eclipses occurred, but of what events followed them, building elaborate systems of divination based on the correlation between celestial events and earthly affairs. These weren't superstitious practices, but sophisticated attempts to find patterns in the apparent chaos of human events. The blood moon became a lens through which to examine the relationship between cosmic order and political stability, between the movements of celestial bodies and the fate of earthly kingdoms. In ancient Egypt, the blood moon was associated with the eye of Horus being wounded in his eternal battle with Set, the god of chaos. The red color represented the blood from Horus's injured eye, and the gradual return to normal brightness symbolized the eye's healing. This myth connected the lunar eclipse to one of the central narratives of Egyptian religion, the ongoing struggle between order and disorder, light and darkness. Egyptian priests developed elaborate rituals to perform during lunar eclipses, designed to assist Horus in his battle and ensure the restoration of cosmic order. Temples would fill with the sound of chanting and the smoke of incense, as worshippers participated in the celestial drama unfolding overhead. The priests understood that they weren't merely observers of this cosmic event. They were active participants, their rituals and prayers, helping to tip the balance toward light and order. The timing of these ceremonies was crucial. As Earth's shadow began to creep across the moon's surface, the temple bells would ring, calling the faithful to gather. As the eclipse progressed and the moon's color deepened from silver to copper to deep red, the intensity of the rituals would increase. Drums would beat in rhythm with the priest's chants, creating a soundscape that seemed to pulse with the wounded moon itself. The Inca civilization of South America saw blood moons as times when a jaguar was devouring the moon. This wasn't seen as entirely negative. Jaguars were powerful, sacred animals associated with shamanic transformation and the ability to move between worlds. The blood moon represented a time when the boundaries between different realms became permeable, when spiritual energy was particularly strong. During these eclipses, Inca communities would perform ceremonies designed to protect their crops and livestock from the jaguar's influence, while also harnessing its transformative power. The red moon was simultaneously dangerous and sacred, a time that required both caution and reverence. African cultures developed diverse interpretations of the blood moon. Some saw it as the moon being attacked by celestial leopards, while others interpreted it as the moon falling ill and needing healing. In many traditions, the community would gather to sing songs and tell stories designed to comfort the moon during its time of distress, treating the celestial body as they might a suffering member of their own family. This caring response to the moon's apparent distress reveals something profound about how these cultures understood their relationship to the cosmos. Rather than seeing themselves as separate from or subject to celestial forces, they saw themselves as participants in a cosmic community, with obligations to care for celestial beings just as they would care for earthly ones. European folklore developed its own interpretations of the blood moon, often connecting it to themes of transformation and prophecy. In medieval times, the red moon was sometimes seen as a sign that werewolves would be particularly active, or that witches were gathering for their most powerful rituals. The blood moon became associated with times when the normal rules didn't apply, when magic was stronger, and when the boundary between the natural and supernatural became thin. These stories weren't just entertainment, they served as ways of processing the psychological impact of witnessing something that challenged normal expectations. The blood moon was a time when anything seemed possible, when the familiar world revealed hidden depths of strangeness and mystery. What's remarkable about all these diverse myths and legends is how they capture something essential about the experience of witnessing a blood moon. Even today, when we understand the physics of lunar eclipses, people often describe feeling a sense of primal unease or awe when they see the moon transformed. The myths acknowledge this emotional reality. They validate the sense that something significant is happening, that this is not just another night. The stories also reveal how different cultures use the blood moon to explore fundamental questions about the nature of reality. Is the cosmos orderly or chaotic? Are celestial bodies distant and indifferent, or intimate and connected to earthly life? Do supernatural forces intervene in natural events? The blood moon became a canvas on which to project these deep philosophical questions. Modern research in psychology suggests that humans have an innate tendency to see agency and intention in unusual natural events, a cognitive bias that helped our ancestors survive by erring on the side of caution when faced with potential threats. The blood moon, being both unusual and visually striking, would naturally trigger these deep-seated patterns of interpretation. But the myths also reveal something more sophisticated, the human capacity to transform fear into story, to take the unknown and make it comprehensible through narrative. Rather than simply being terrified by the moon's transformation, cultures around the world created rich, complex stories that gave meaning to the experience. These ancient stories continue to influence how we think about blood moons today. Even people who understand the science often find themselves drawn to the mythological associations, the sense of drama, transformation, and cosmic significance. The blood moon carries with it the weight of thousands of years of human storytelling, making each eclipse not just an astronomical event, but a connection to the deepest roots of human culture and imagination. Perhaps most remarkably, these diverse mythological traditions share common psychological insights about human nature and our relationship to the cosmos. They recognize that certain natural events trigger responses that go beyond mere intellectual curiosity. They touch something primal and profound in the human psyche. The myths validate the sense that witnessing a blood moon is different from simply reading about one, that there's something transformative about standing beneath that red light and feeling connected to the cosmic machinery that creates it. The stories also reveal how different cultures use the blood moon as a teacher, a reminder of important truths about the nature of change, the temporary nature of all things, and the interconnectedness of earthly and celestial events. Whether the moon was being devoured by a dragon or wounded in cosmic battle, the message was similar. Nothing remains the same forever. Even the most reliable aspects of our experience are subject to transformation. In this way, the blood moon became a kind of meditation on impermanence, a celestial koan that challenged observers to confront their assumptions about stability and change. The myths helped people process not just the visual spectacle of the eclipse, but its deeper implications about the nature of existence itself. As we turn our attention to the modern scientific understanding of blood moons, we carry with us this rich heritage of wonder and interpretation. The myths remind us that knowledge and mystery can coexist, that understanding how something works doesn't diminish its capacity to move us, to connect us to something larger than ourselves, to inspire the kind of awe that has driven human curiosity since our species first looked up at the night sky and tried to make sense of what we saw there. To truly understand why a blood moon glows red, we need to dive deeper into the invisible architecture of light itself, not just the simple explanation of wavelengths and scattering, but the elegant physics that transforms our entire planet into a cosmic lens, bending and filtering starlight in ways that would seem magical if we didn't understand the science behind them. Let's begin with something you can observe right now wherever you're listening. Look around you at the colours in your immediate environment, the warm wood of a table, the cool blue of a computer screen, the soft green of a plant by the window. Every one of these colours exists because of the same fundamental process that creates the blood moon's ethereal glow. They're all the result of light interacting with matter, wavelengths being absorbed, reflected, or scattered in patterns that our eyes interpret as the rich palette of the visible world. Light, as we've discovered, is both simpler and more complex than our everyday experience suggests. At its heart, it's electromagnetic radiation, oscillating electric and magnetic fields that ripple through space at nearly 300 million meters per second. But within that seemingly uniform phenomenon lies hidden structure, a spectrum of different wavelengths that each carry their own character and behavior. When we talk about red light having a wavelength of about 700 nanometers, we're describing something almost impossibly small. A nanometer is 1/1000th of a meter, so tiny that if you lined up 700 nanometers end to end, they would span less than the width of a bacterium. Yet this microscopic distance determines something as grand as the colour of the blood moon hanging in the night sky. The key to understanding the blood moon lies in a phenomenon discovered by Lord Rayleigh in the 1870s, now known as Rayleigh scattering. This process governs how light behaves when it encounters particles much smaller than its own wavelength, particles like the molecules of nitrogen and oxygen that make up the bulk of our atmosphere. Picture a wave rolling toward a beach. If that wave encounters a large rock jutting out of the water, it crashes against it, creating spray and turbulence. But if the same wave passes over a small pebble on the ocean floor, it barely notices. The pebble is too small to significantly disrupt the wave's progress. Light behaves similarly when it encounters particles in the atmosphere. The molecules in our air, mostly nitrogen and oxygen, are much smaller than the wavelengths of visible light. When light waves encounter these tiny particles, something subtle but profound happens. The oscillating electric field of the light wave causes the electrons in the gas molecules to oscillate as well, turning each molecule into a miniature antenna that re-radiates light in all directions. But here's where it gets interesting. This re-radiation isn't uniform across all wavelengths. The intensity of the scattered light depends on the wavelength raised to the fourth power, a mathematical relationship that creates dramatic differences in how various colours behave. Blue light, with its shorter wavelength of about 450 nanometers, is scattered much more strongly than red light, with its longer wavelength of 700 nanometers. The difference isn't subtle. Blue light is scattered about 5 times more intensely than red light. This is why our daytime sky appears blue. The sun's white light enters the atmosphere. The blue wavelengths get scattered in all directions, and no matter where we look in the sky, some of that scattered blue light reaches our eyes. But the story becomes more complex when we consider the journey that light takes during a lunar eclipse. Instead of travelling straight down through the atmosphere like sunlight at noon, the light that illuminates a blood moon has travelled around the edge of our entire planet, grazing the atmosphere at the most oblique possible angle. Imagine Earth's atmosphere as a series of concentric shells, each with slightly different density, temperature and composition. The light from the sun approaching Earth during a lunar eclipse doesn't plunge straight through these layers. Instead, it skims along their edges, passing through hundreds of kilometers of air that gradually thin into the vacuum of space. This grazing passage creates what physicists call a very long optical path, the total distance that light travels through the atmosphere. While the atmosphere itself might be only about 100 kilometers thick, light travelling along Earth's curved edge can pass through the equivalent of thousands of kilometers of air, encountering countless opportunities for scattering. During this extended journey, the blue wavelengths, already more prone to scattering, get bounced away in random directions, rarely making it all the way around Earth's limb to reach the moon. It's like a game of pinball where the blue light gets caught up in endless collisions with atmospheric molecules, losing its way in the maze of scattering events. The red wavelengths, meanwhile, push through more directly. They're not immune to scattering, but their longer wavelength makes them less likely to be diverted from their path. By the time light completes its journey around Earth's edge and continues toward the moon, it has been stripped of most of its blues and violets, leaving behind the warm reds, oranges, and deep yellows that give the blood moon its distinctive colour. But scattering is only part of the story. Our atmosphere doesn't just filter light, it also acts as a lens, bending the light through refraction. This happens because light travels at different speeds through different materials. In the vacuum of space, light moves at its maximum speed. But when it enters Earth's atmosphere, it slows down slightly as it interacts with the gas molecules. This change in speed causes the light rays to bend following a curved path rather than a straight line. The effect is strongest where the atmosphere is thickest and becomes gradually weaker as the air thins out at higher altitudes. The result is that our atmosphere acts like a massive lens wrapped around the entire planet, focusing some of the sun's light into Earth's shadow zone. Without this atmospheric refraction, lunar eclipses would be much darker, possibly dark enough that the moon would disappear completely during totality. But the bending effect of our atmosphere ensures that some sunlight always finds its way around Earth's edges, providing the gentle illumination that creates the blood moon's glow. The amount of bending depends on the wavelength of light in a phenomenon called atmospheric dispersion. Red light bends slightly less than blue light as it passes through the atmosphere, which means that different colours take slightly different paths as they curve around Earth's edge. This subtle effect contributes to the complex colour variations we see during different lunar eclipses. The density structure of Earth's atmosphere also plays a crucial role in determining the exact appearance of each blood moon. Our atmosphere isn't uniform. It has layers with different temperatures, pressures, and compositions. The troposphere, where weather occurs, extends up to about 12 kilometres and contains most of the atmosphere's mass. Above that lies the stratosphere, reaching up to about 50 kilometres, followed by the mesosphere and thermosphere extending hundreds of kilometres into space. Each of these layers affects light differently. The troposphere, with its water vapour, dust and varying pressure systems, creates most of the variable effects we see in blood moon colours. A high-pressure system with clear, stable air will allow more light through, creating a brighter, more orange-coloured eclipse. A low-pressure system with clouds, moisture or particles in the air will absorb more light, making the moon appear darker and redder. The stratosphere contains the ozone layer, which absorbs some ultraviolet light, but generally has less impact on the visible colours we see during eclipses. However, when major volcanic eruptions inject ash and sulfur compounds into the stratosphere, they can remain suspended there for months or years, significantly affecting the appearance of lunar eclipses. The 1991 eruption of Mount Pinatubo provides a clear example of how atmospheric composition affects blood moons. The volcano ejected so much material into the stratosphere that lunar eclipses for the next several years appeared much darker than usual. The ash and sulfur aerosols didn't just scatter light, they absorbed it, reducing the total amount of illumination reaching the moon and intensifying the red coloration of the remaining light. Temperature gradients in the atmosphere also affect how light bends as it passes through. Hot air is less dense than cold air, creating variations in the refractive index that can slightly alter the path of light rays. These effects are usually subtle, but they contribute to the unique character of each eclipse. The seasonal timing of an eclipse matters too, because the atmosphere's structure changes with the seasons. Winter air in the northern hemisphere tends to be cleaner and more stable, often producing brighter blood moons with more orange and copper tones. Summer air, especially during fire season or periods of high atmospheric dust, can create the deep, dark red eclipses that most closely match the blood moon description. Even the geographic location where the eclipse is viewed affects its appearance. An eclipse seen from a location where its sunset will be illuminated by light passing through Earth's atmosphere at sunset conditions, possibly dusty warm air with particles that enhance the red coloration. The same eclipse viewed from a location where its sunrise might appear lighter and more orange, illuminated by the cleaner, cooler air typically found at dawn. The mathematics governing these processes are elegant in their precision. The scattering intensity follows the fourth power law discovered by Rayleigh, while the refraction follows Snell's law, describing how light bends when moving between materials of different optical densities. Together, these physical principles create a natural optical system that transforms our entire planet into a colour filter and focusing lens. But perhaps most remarkably, this complex interplay of scattering, refraction, and atmospheric structure creates something beautiful rather than chaotic. Despite all the variables involved, the seasonal changes, weather patterns, volcanic activity, and atmospheric composition, the result is consistently a moon that glows with warm, inviting colours that have inspired humans for millennia. The science reveals that the blood moon is illuminated by light that has been on an extraordinary journey. It began in the nuclear fusion reactions at the Sun's core, travelled 150 million kilometres through the vacuum of space, then grazed the edge of our planet, interacting with countless molecules in our atmosphere, before continuing another 384,000 kilometers to the moon. By the time it reaches our eyes, this light carries with it the signature of our entire planet's atmosphere, a chemical and physical fingerprint that tells the story of Earth's air, weather, and seasonal cycles. Each photon of light that colours the blood moon has survived a journey that would challenge even our most sophisticated spacecraft. It has navigated the complex density variations of our atmosphere, been scattered by molecules so small they're invisible even under powerful microscopes, and bent by the subtle gravitational effects of our planet's mass. The fact that any light completes this obstacle course to reach the moon, and that it arrives carrying such beautiful colours, speaks to the remarkable precision of physical laws operating across vast scales of space and time. Standing beneath a blood moon, you're seeing the combined effect of physics operating on scales from the microscopic, individual light waves interacting with gas molecules, to the planetary, Earth's entire atmosphere acting as a lens and filter. It's a reminder that the most beautiful phenomena in nature often emerge from the complex interplay of simple physical laws, creating experiences that are simultaneously scientifically explicable and deeply moving. As we continue our exploration of blood moons, from the practical experience of witnessing one to the modern ways we study and share these events, remember that behind every moment of wonder lies this elegant dance of light and matter. The next time you see sunlight streaming through a window or notice the blue sky overhead, you'll recognize the same physical processes that transform our familiar silver moon into a glowing ember in the night sky, connecting the everyday physics of light to the rare magic of a blood moon. There's something uniquely intimate about witnessing a blood moon in our modern world. In an age where most of our visual experiences are mediated through screens, where we watch high-definition videos of distant galaxies and see photographs of cosmic events moments after they happen, the blood moon offers something different. It asks nothing of you but patience and the willingness to look up. No special equipment needed, no technical knowledge required. Just you, the night sky, and one of nature's most accessible cosmic spectacles. The first thing to understand about observing a blood moon is that it unfolds slowly, like a meditation stretched across hours rather than minutes. This isn't the quick flash of a meteor or the brief transit of the International Space Station. A lunar eclipse is astronomy at the pace of a gentle river, giving you time to settle in, to really see what's happening, and to let the experience sink in. The entire event typically lasts between 3 to 6 hours from first contact to final departure from Earth's shadow. But the most dramatic phase, totality, when the moon glows its deepest red, can last anywhere from a few minutes to over an hour, depending on the eclipse's geometry and the moon's path through Earth's shadow. Planning to watch a blood moon begins with understanding when and where it will be visible. Unlike solar eclipses, which are only visible along narrow paths on Earth's surface, lunar eclipses can be seen from anywhere on the nighttime side of our planet. If you can see the moon during the eclipse, you can see the blood moon. This makes them far more accessible than their solar cousins. No need to travel to remote locations or worry about being in the right place at exactly the right time. The timing matters, though. The best viewing experience comes when the moon is high in the sky, away from the visual interference of buildings, trees, and the thick atmosphere near the horizon. A blood moon viewed when it's low on the horizon will appear dimmer and more orange due to the additional atmospheric filtering, though this can create its own kind of beauty. Weather is the great variable in any astronomical observation, and blood moons are no exception. Cloud cover can completely obscure the event, and there's little you can do about it except hope for clear skies. But unlike viewing faint galaxies or nebulae, blood moons are bright enough that they can sometimes be seen through thin clouds, creating an ethereal, diffused glow that adds its own character to the experience. Temperature is another consideration, especially for eclipses that occur during winter months. Blood moons often happen in the early morning hours when temperatures are at their lowest. Dressing warmly becomes part of the ritual. Layers of clothing, warm beverages, perhaps a comfortable chair or blanket. The goal is to be comfortable enough to stay outside for hours without the cold distracting from the celestial show. The viewing experience itself is unlike almost anything else in astronomy. Most astronomical objects require telescopes or binoculars to see properly, but a blood moon is best appreciated with the naked eye first. Your eyes naturally take in the entire lunar disk, allowing you to see the gradual progression of Earth's shadow across the moon's surface and the slow transformation of colour as totality approaches. The eclipse begins subtly. The moon enters Earth's penumbra first, dimming almost imperceptibly. Most people don't notice this initial phase. The change is too gradual and too faint. It's like watching the sunset. You know it's happening, but the moment-to-moment changes are difficult to detect. But then, usually about an hour into the eclipse, something more dramatic begins. A subtle bite appears at one edge of the moon, the beginning of partial eclipse, as the moon enters Earth's umbra. This is when most observers first notice that something unusual is happening. The bite grows larger, Earth's curved shadow creeping across the lunar surface, like slow, dark water flowing over a silver coin. The shadow isn't uniformly black. It has depth and character, often appearing brownish or rust-coloured even during the partial phases. As more of the moon disappears into the shadow, the contrast becomes more striking. The bright, silver-white portion still in sunlight appears almost blindingly brilliant next to the darkened reddish area covered by Earth's shadow. This is also when you might notice something unexpected. Stars begin to appear near the moon that were previously invisible. The moon's normal brightness washes out faint stars in its vicinity, but as the eclipse progresses and the moon dims, these stars emerge like shy creatures coming out after dark. The sky around the eclipsed moon becomes richer, more textured with points of light. As totality approaches, the last sliver of bright moonlight shrinks to a thin crescent, then to a tiny arc of brilliance clinging to one edge of the lunar disk. The moment when this final bright point disappears marks the beginning of totality, and the transformation is often more dramatic than first-time observers expect. The moon doesn't vanish. Instead, it emerges from the darkness transformed. Where moments before there was harsh silver light, now there's a gentle warm glow the colour of burnished copper or dying embers. The change in the quality of light is immediately noticeable. Moonlight during totality is soft, almost caressing, so different from the moon's usual brilliance that it seems like a different celestial body entirely. The colour during totality is never quite the same from one eclipse to another. Sometimes the moon appears bright orange, like a basketball hanging in the sky. Other times it's a deep, dark red, so dim you have to look carefully to make sure it's still there. Occasionally it takes on a brownish hue, like old leather, or even a coppery gold that seems to pulse gently in the darkness. These colour variations depend on Earth's atmospheric conditions during the eclipse. If you're witnessing a blood moon that appears particularly dark, you might be seeing the effects of volcanic ash or dust storms on the other side of the planet, filtering the light that's being bent around Earth's edge. If it's bright and orange, you're probably seeing the effects of clear, stable air that's allowing more light to pass through. During totality, the moon often seems smaller than usual. This isn't an optical illusion. The eclipse typically makes the moon appear to shrink because you're seeing it by much dimmer light than usual. Without the bright reference points you're accustomed to, your brain struggles to gauge the moon's size, often making it seem more distant and compact. The landscape around you changes too during totality. If you've been outside for the entire eclipse, you'll notice that the world has grown darker as the moon's light has dimmed. Shadows that were sharp and well-defined under the bright full moon become softer and less distinct. Colours in the landscape appear muted, and there's often a sense of hushed expectancy, as if the natural world is holding its breath. Some observers report that animals behave differently during lunar eclipses. Dogs might become restless, birds sometimes fall silent, and insects may change their patterns of activity. While these effects aren't as pronounced as during solar eclipses, there's something about the unusual quality of light during totality that seems to affect the natural world in subtle ways. The best viewing position for a blood moon is anywhere with a clear view of the sky where the moon will be during the eclipse. This might be your backyard, a nearby park, or even an urban rooftop. Unlike many astronomical phenomena, blood moons are visible from cities despite light pollution. The moon during totality is bright enough to overcome most urban sky glow, though the darkest eclipse phases might be harder to see from very light-polluted areas. Many observers find that binoculars enhance the experience, though they're not necessary. Binoculars can reveal subtle colour variations across the moon's surface during totality and make it easier to see the progression of Earth's shadow during the partial phases. They also help if the eclipse occurs when the moon is low on the horizon and appears dimmer due to atmospheric filtering. Photography of blood moons has become increasingly popular, and modern cameras, even smartphones, can capture the event reasonably well. The key is understanding that the moon during totality is much dimmer than normal, requiring longer exposures or higher sensitivity settings. Many photographers enjoy creating time-lapse sequences showing the eclipse's progression, or composite images that show multiple phases of the eclipse in a single frame. For those interested in photography, a few practical considerations can enhance the results. A tripod becomes essential for the longer exposures needed during totality, as even the steadiest hand can't eliminate camera shake during multi-second exposures. Scout your location in advance, checking for obstacles like trees or buildings that might block the moon's path as it moves across the sky during the eclipse. Manual camera settings work best for lunar eclipse photography. Start with the settings you'd use for a normal full moon, then adjust as the eclipse progresses and the moon dims. During the partial phases, shorter exposures preserve the detail in the bright portion while capturing the shadow's progression. During totality, longer exposures reveal the full colour and subtle surface details that the dimmer light makes possible to capture. But perhaps the most rewarding approach is to spend some time simply watching, without trying to photograph or document the event. There's something meditative about sitting under the night sky for hours, watching this slow cosmic dance unfold. It's a chance to disconnect from the rapid pace of modern life and sync up with astronomical time, deep, patient, and measured in centuries rather than seconds. The end of totality is as gradual as its beginning. A thin sliver of bright sunlight appears at one edge of the moon, and slowly, over the course of another hour or more, the normal silver moonlight returns. The eclipse doesn't end abruptly. It fades away like a dream, leaving behind the familiar full moon that was there at the beginning. For many people, witnessing their first blood moon becomes a memorable experience that connects them to astronomy in a new way. There's something profound about seeing celestial mechanics play out in real time, about understanding that you're watching Earth cast a shadow in space and seeing that shadow painted with the light of every sunset and sunrise happening around our planet's edge. The beauty of observing blood moons in our current era is that we can appreciate them on multiple levels simultaneously. We can understand the physics that creates the phenomenon while still being moved by its visual beauty. We can predict exactly when it will happen while still feeling surprised by the moment when the familiar moon transforms into something alien and wonderful. In an age of virtual experiences and digital mediation, the blood moon offers something irreplaceably real. It's happening right now, in real time, in the actual sky above your head. No screen can replicate the experience of standing under the open sky for hours, feeling the temperature drop as the night progresses, watching this ancient dance of shadows and light unfold at the stately pace of cosmic time. The next blood moon you have the opportunity to witness will be unique, different from every other eclipse you might see, shaped by atmospheric conditions that exist only in that moment, coloured by light that has travelled an impossible distance to reach your eyes. It's an invitation to step outside, look up, and remember that we live on a planet spinning through space, casting shadows into the cosmic darkness, part of a solar system whose clockwork precision has been running for billions of years and will continue long after we're gone. As we reach the end of our gentle journey through the science and wonder of blood moons, it feels fitting to pause and reflect on what this celestial phenomenon teaches us about ourselves, our planet, and our place in the vast cosmos that surrounds us. The blood moon, in all its quiet majesty, offers lessons that extend far beyond the mechanics of shadows and scattered light. There's something profound about standing beneath a blood moon that connects us to the deepest currents of human experience. For thousands of years, our ancestors looked up at this same transformation, the familiar silver moon becoming something warm and red and mysterious, and felt that mixture of awe and curiosity that drives us to ask questions about the world around us. In that sense, witnessing a blood moon today makes us part of an unbroken chain of wonder that stretches back to the very beginning of human consciousness. The blood moon reminds us, perhaps more than any other astronomical event, that we are not separate from the cosmos, but intimately connected to it. The red light that colours the eclipsed moon has passed through the same atmosphere we breathe, been filtered by the same air that sustains every living thing on our planet. When you see a blood moon, you're literally seeing the combined light of every sunrise and sunset happening on Earth at that moment, focused and concentrated into a gentle glow that travels 250,000 miles to reach your eyes. This connection runs deeper than just the physics of light. The blood moon exists because Earth, moon and sun move together in a cosmic dance that has been choreographed by gravity and orbital mechanics for billions of years. We are passengers on one of those dancers, Earth, witnessing the shadow play that results from our planet's movement through space. The eclipse happens not to us, but with us as we spin and orbit our way around the sun, carrying the moon along as our faithful companion. In our modern world, where so much of our experience is mediated by screens and filtered through technology, the blood moon offers something irreplaceably direct. It requires no apps to interpret, no devices to enhance, no digital processing to make it meaningful. It simply is a natural phenomenon unfolding in real time above your head, beautiful and comprehensible to anyone willing to look up and pay attention. This directness feels increasingly rare in our hyper-connected age. We can watch live streams of eclipses from around the world, see high-resolution photographs that capture details invisible to the naked eye, and access real-time data about atmospheric conditions and eclipse timing. All of these technological tools enrich our understanding, but they cannot replace the fundamental experience of standing under the actual sky, feeling the night air on your skin, and seeing with your own eyes as the moon transforms from silver to copper to deep red. The blood moon also teaches us about time, not the rushed, fragmented time of our daily schedules, but astronomical time, deep time, the patient rhythm of celestial mechanics. Lunar eclipses unfold over hours, not seconds. They ask us to slow down, to wait, to let our attention settle into a different pace entirely. In a world that often feels like it's accelerating beyond our ability to keep up, the blood moon offers an invitation to sync up with something more fundamental, the stately progression of planetary motion that has been constant for eons. This temporal perspective can be both humbling and comforting. The same eclipse mechanics we witness today operated when the first humans walked the Earth, when dinosaurs roamed the planet, even when life itself was just beginning in ancient oceans. The blood moon connects us to deep time in a visceral way, reminding us that we are part of processes much larger and older than our individual lives, or even our species. Yet there's also something deeply personal about witnessing a blood moon. No two people see exactly the same eclipse. Your particular viewing location, the atmospheric conditions above you, even the personal associations and memories you bring to the moment all contribute to making your experience unique. The blood moon becomes a kind of mirror, reflecting not just Earth's shadow but our own capacity for wonder, our need to find meaning in natural phenomena, our desire to understand our place in the larger scheme of things. The scientific understanding we've explored throughout our journey, the Rayleigh scattering, the atmospheric refraction, the interplay of shadow and light, doesn't diminish this sense of wonder. Instead, it deepens it. Knowing why the moon turns red makes the phenomenon more remarkable, not less. Understanding the precise choreography of orbital mechanics that creates the eclipse adds layers of appreciation that enhance rather than replace the simple beauty of seeing the transformed moon hanging in the night sky. This is perhaps one of the blood moon's most important lessons. Knowledge and mystery can coexist. Scientific understanding doesn't eliminate wonder. It provides new dimensions for wonder to explore. The more we understand about the elegant physics that creates the blood moon, the more remarkable it becomes that such beauty emerges from fundamental forces and mathematical relationships. The blood moon also reminds us of our shared humanity. When a lunar eclipse occurs, it's visible from roughly half the Earth, potentially billions of people all looking up at the same transformed moon. In that moment, despite all our differences in culture, language, and belief, we share a common experience. We are all witnesses to the same cosmic event, all connected by the simple act of looking up and marveling at the same red glow in the night sky. This shared perspective has the power to put our earthly concerns in a broader context. The problems that seem overwhelming from ground level, the conflicts, divisions, and challenges that dominate our news cycles, shrink when viewed from the cosmic perspective that the blood moon provides. We are reminded that we all live on the same small planet, sharing the same atmosphere that filters the sunlight to create the blood moon's glow. All equally tiny observers of forces vast beyond our individual comprehension. Standing beneath a blood moon, you might feel a profound sense of both insignificance and significance simultaneously. Insignificant because you're witnessing processes that operated billions of years before you were born and will continue long after you're gone. Significant because you are conscious, aware, capable of understanding what you're seeing and finding beauty in it. This paradox, feeling both infinitely small and uniquely precious in the same moment, captures something essential about what it means to be human in a vast cosmos. The blood moon teaches patience too. In our instant gratification culture, where we expect immediate results and rapid changes, the eclipse unfolds according to its own schedule. It cannot be rushed, cannot be made more convenient for our schedules, cannot be compressed into a highlight reel. It demands that we adjust our expectations to match its rhythm, that we give it the time it needs to reveal its full beauty. This patience extends to the larger cycles of astronomical events. Blood moons don't happen every month, despite the moon being full every month. The precise alignment required, Sun, Earth and Moon in a straight line, occurs only when the moon's slightly tilted orbit carries it through Earth's shadow. These eclipses come in clusters, separated by months or years, following patterns that ancient astronomers learned to predict but could never control. The rarity of blood moons makes each one more precious. Unlike the sun and moon, which we can see any day, or the stars, which appear every clear night, a blood moon is an event, something that happens rather than something that simply is. This scarcity adds weight to the experience, making it feel like a gift rather than an entitlement. As we've seen throughout human history, the blood moon has inspired stories, shaped cultures, and driven scientific inquiry. It has been both omen and object of study, both mystery and mechanism. In our current era, we have the unique privilege of understanding the physics while still being moved by the poetry, of predicting the timing while still feeling surprised by the beauty. The blood moon stands as a reminder that the universe is both stranger and more wonderful than our everyday experience suggests. We live on a planet that casts shadows into space, orbited by a moon that can be lit by the light of distant sunsets. We inhabit a cosmos where the simple interaction of light and matter creates displays of beauty that have inspired human beings for millennia. Perhaps most importantly, the blood moon reminds us that wonder is always available to us. In a world that can feel increasingly artificial and disconnected from natural rhythms, the night sky remains a source of genuine awe and authentic experience. You don't need special training to appreciate a blood moon, don't need expensive equipment to see it, don't need to travel to exotic locations to witness it. You just need to look up. But this accessibility carries with it a responsibility to ourselves and to future generations. The night sky that has inspired humans for millennia is under threat from light pollution, which now obscures the stars for most people living in cities. While blood moons are bright enough to be seen even through urban light pollution, the broader celestial tapestry that gives context to such events, the star fields, the Milky Way, the subtle dance of planets, is increasingly invisible to much of humanity. Protecting our ability to see the night sky isn't just about preserving astronomical observations, it's about maintaining our connection to the cosmos of which we're part. The artificial lights that wash out the stars also disconnect us from the natural rhythms that guided our ancestors and remind us of our place in the larger scheme of things. In that simple act, looking up, we connect ourselves to every human who has ever lived, all of whom have shared the same sky, many of whom have witnessed the same transformation we see when the moon turns red. We become part of the continuing story of human curiosity and wonder, adding our own moment of awe to a narrative that began when our species first learned to see meaning in the movements of celestial bodies. The next time you find yourself beneath a clear night sky, take a moment to look up. The moon might be its familiar silver self, or perhaps just a thin crescent, or maybe not visible at all. But knowing that it's there, our faithful companion that occasionally puts on the spectacular show of a blood moon, can be enough to kindle that sense of connection to the larger cosmos of which we are all part. The blood moon in the end is both simpler and more complex than it first appears. Simple because it's just a shadow and some scattered light. Complex because it emerges from the intricate dance of three celestial bodies, the physics of electromagnetic radiation and the chemistry of our atmosphere. But perhaps its greatest gift is the way it brings these scales together, the cosmic and the personal, the ancient and the immediate, the scientific and the spiritual, into a single beautiful experience of standing under the night sky and marveling at the wonders that surround us. As you drift towards sleep tonight, whether you're listening to these words under a star-filled sky or in the comfort of your own room, remember that the same cosmos that creates the blood moon's gentle glow surrounds you always. The same forces that bend light around our planet's edge, the same gravity that guides the moon in its orbit, the same nuclear fusion that powers the sun, all of it is part of the vast, interconnected system of which you are also a part. In that knowledge, there is both humility and wonder, both science and poetry, both the satisfaction of understanding and the endless invitation to keep looking up and asking questions about the beautiful, mysterious universe we call home. Sweet dreams within this cosmic embrace, knowing that you carry within yourself the story of starlight and shadow, of ancient wisdom and modern understanding. In your capacity for wonder and curiosity, you represent something remarkable, the universe becoming aware of itself, finding beauty in its own elegant processes. This is the sleepy astronomer, wishing you the most peaceful rest beneath the gentle glow of moonlight and starshine, and reminding you that you too are part of this cosmic dance of light and shadow, forever woven into the infinite story of the night sky.